All right, we are up to lesson 14 of Unit 6 now. So since there are no new lesson notes, let's go right into the examples. Basically, in this lesson, we're going to go the opposite of what we did yesterday. So here are three equations for three different windmills. Each equation describes the height, h in feet above the ground of a point at the tip of a blade of a different windmill. The point is at the far right when the angle theta takes the value 0. Describe each windmill and how it is spinning. So let's start with number 1. So number 1, the A value in front of the sign is 2.5. So if we go back and look at the previous lesson notes, okay, the A value is 2.5. So that tells me that the amplitude is 2.5, which means if the amplitude is 2.5, that represents the length of the windmill blade. Okay? So that represents the length of the windmill blade or the radius. Okay? So in number 1, the length of the windmill blade is 2.5, and it would be 2.5 feet. Okay. Notice there's no number inside with theta, so that means, again, going back to our notes, there's no number inside the parentheses with theta or x, so that tells me the C value is 0, which means it's starting at the 0 radian position. All right, so that should not be a surprise because they told us that. And then plus 10, so the plus 10 after the parentheses, okay, the plus 10 after the parentheses, okay, that tells me that the midline is 10. And if the midline is 10, then that means the height of the center is 10 feet. So the height of the center is 10 feet. Okay. And then the only other thing is how it is spinning. So in other words, is it spinning clockwise or counterclockwise? Well, to figure that out, okay, if the A value is negative, the windmill is spinning in a negative direction. In this case, the A value was positive. It was 2.5. So it is spinning in the positive direction, which means it's spinning counterclockwise. So it's spinning counterclockwise. So for number 1, the blade has a length of 2.5 feet. The center of the windmill is 10 feet above ground. Okay. And it's spinning counterclockwise. Okay. Let's go to number 2 now. So number 2, now the length of the windmill blade, instead of being 2.5 feet, is going to be 4/5 of 1 feet. So it's going to be 4/5 feet. As a decimal, 4/5 is going to be 0.8. So 4/5 is the same as 0.8. So the blade is only 0.8 feet long instead of 2.5 feet. The height of the center, in this case, instead of 10 feet, is going to be 3 feet. And once again, that A value was positive, positive 4/5. So it's spinning counterclockwise. Okay. Lastly, number 3. Okay. Once again, the length of the windmill blade okay, instead of being 2.5 feet or 4/5 feet. Notice this value is now negative 1.5. So the absolute value of negative 1.5 is positive 1.5. So the length of the blade is 1.5 feet. What that negative means is that it's going to be spinning, instead of spinning counterclockwise, it's going to be spinning clockwise. Okay, so that's the only thing that negative 1.5 means. It still tells me that the length of the blade is 1.5 feet, but it's now spinning clockwise instead of counterclockwise. And the height of the center is equal now to 5 feet. Okay, so all we were doing is, based on our equation, we were using the amplitude to figure out the length of the windmill blade. We also used the amplitude to determine what direction it was spinning, counterclockwise or clockwise. And then we used our midline. So these were our 3 midlines to determine the heights of the center of the windmill. And that is it for this lesson.